everyone. Welcome back to Exploring the Coast with Hannah. On this week's episode, we're going to be looking at surfgrass communities and their importance here in Monterey Bay. Let's go.
There are two species of surfgrasses found here in Monterey Bay, Phyllospadix scouleri and Phyllospadix torreyi. Surfgrasses are true perennial plants and not an algae, and are found in rocky intertidal habitats. These surfgrass species are often misidentified as eelgrass, which genus is Zostera, and are different from surfgrasses. Surfgrasses are only found in rocky shore habitats, as opposed to eelgrass, which is found in sandy habitats. Phyllospadix scouleri has a very wide distribution and can be found from Sitka, Alaska, all the way down to Baja California. They are mostly found on rocks that have no sand. Their blades are usually wider than 2 inches, and they reach lengths no longer than 3 feet. Phyllospadix torreyi has a smaller distribution than that of scouleri. You can find torreyi from Vancouver Island, British Columbia, all the way down to Baja California. They have thinner blades that are less than 2 inches wide. They are more wiry, longer than 3 feet, and can reach up to lengths of 10 feet. They are more likely found in rocky, sandy scoured areas than scouleri. Here you can see the long strand of torreyi surfgrass. So why are surfgrass communities so important? Well, for one, they're one of the most productive marine primary producers. They collect suspended sediments in the water that help build shoreline and prevent erosion. They aid in water clarity. They provide habitat for many vertebrate, invertebrate, and algal species, including habitat for the California spiny lobster, which is commercially important. They also protect intertidal and shoreline habitats from big surf. They are an indicator species due to their sensitivity to pollution, and they also sequester carbon. There are many threats that surfgrasses face. The biggest one is pollution. Another one is coastal development. Surfgrasses have slow, regenerative properties, and once damaged or killed, it is very hard for those surfgrass habitats to grow back to what they once were. There have been some human restoration efforts, but most have been unsuccessful. They also have a non-native species that they can compete with called Caulerpa taxifolia. Surfgrasses also have to deal with natural threats and are prone to desiccation during midday low tides and will turn yellow, brown, or white, as you can see here in this photo. Here are some of the animals that you can find in the surfgrass beds. They include nudibranchs, anemones, crabs, and sea stars. Here is an awesome underwater video of surfgrasses in the subtidal zone. You can see that many fishes, including the Garibaldis you see here, which is California's state fish, depend on these habitats for protection and finding food. The long-term monitoring program and experiential training for students, also known as LIMPETS, has been monitoring surfgrass beds for decades. The two sites that LIMPETS monitors at are Opal Cliffs and Soquel Point in Santa Cruz, California, in northern Monterey Bay. Surfgrass monitoring at Opal Cliffs and Soquel Point started in the early 1970s by LIMPETS founder Dr. John Pierce and his students at the University of California, Santa Cruz, when Dr. Pierce found out that treated sewage was being dumped directly into the intertidal at Soquel Point, killing off a large area of surfgrass. A comparison site at Opal Cliffs was set up, which sits about 1 kilometer east of Soquel Point. In 1976, Santa Cruz County finally stopped the discharging of the sewage. Monitoring continued with Dr. Pierce and his team until 2003 when the LIMPETS program picked it up. The LIMPETS program continues to monitor every year in June or July. All of our surfgrass monitoring is done by students or volunteers. Without their help, this research would not be possible. Some of them have continued coming out year after year to help us collect data on these critical habitats. Here are our results that we found through our monitoring. Initially, coralline algae took over the areas where surfgrass had been killed at Soquel Point. Surfgrass at Soquel Point recovered very slowly, taking over 20 years to become a similar size area to that of Opal Cliffs. The coralline algae eventually declined in abundance at Soquel Point. Since the mid-1990s, the two plots have remained largely unchanged. However, coralline algae at Soquel Point is more abundant than at Opal Cliffs. This long-term research on surfgrass communities has been possible due to Dr. Pierce's and all of our wonderful volunteers' passion and commitment to understanding these important habitats and the vital role they play in Monterey Bay. Thank you so much for joining me today. Don't forget, a new video of Exploring the Coast with Hannah drops every Tuesday at 11 a.m. on the Pacific Grove Museum of Natural History's website on the Museum to You page.